Hello everybody and welcome. This is Mr. Cantor and this is Modeling with Mr. Cantor. Today we're going to be looking at Explore Part B. Now, before we begin, I want you to please pause this video, read the story to yourself, and let me know what do you notice and what do you wonder. Alright, welcome back. Now, let's read the story together. The story says, decide which histogram shows the heights of baseball players and which shows the heights of basketball players. Be prepared to explain your reasoning. So, some of the things that you might have noticed and some of the things that you might have wondered is what are these two histograms even talking about? And we can see that the x-axis for both of these histograms talks about the height in inches. This one isn't labeled, but this one is also height in inches. We know this because the numbers on the x-axis are exactly the same. They start at 66 and they range all the way to 88. This one starts at 66 and ranges to 90. On the y-axis, we start from 0 and we go to 20, and they both do that as well. So, the x-axis represents the height in inches, but what does the y-axis represent? Please pause the video and let me know. Alright, welcome back. If you said the y-axis represents the amount of players for each one of these different bars, then you are correct. So, we're looking at two different histograms. And one is going to represent the baseball players, and one is going to represent the basketball players. Please pause this video and let me know, which histogram do you think represents the baseball players and which one do you think represents the basketball players? Alright, welcome back. If you said that histogram A shows the heights of professional basketball players because the cluster of the bars are located higher on the number line compared to those in the histogram B, which means they represent taller players, then you are correct. We can see that in histogram A, the players whose heights range from 74 to 86, there are quite a few of them, and they are all in the zone clustered together. And if we look at histogram B, even though we have a lot of players who are between 72 and 74 inches tall, the majority of tall players are actually in histogram A, because in histogram A, all of these players that are in the major cluster area are between 74 and 86 inches tall. Those are really tall players. Whereas here, we're looking at the majority of players being between 66 and 80. These go as far as 88, maybe even 89. So definitely histogram A is going to be our basketball players, and histogram B is going to be our baseball players. If that's what you said, good job. So with that, let's move on. Here we go. We have the exact same two histograms, and they're asking us two questions. What I want you to do is to please pause this video, read question 2 to yourself, try to answer it, and then we will read it together and answer it together. Alright, welcome back. Question number 2 reads, write 2 to 3 sentences that describe the distribution of the heights of the basketball players. Comment on the center and spread of data. Okay, so we said that histogram A is referring to the basketball players. If you said the basketball players' data distribution is centered at around 80 to 81 inches, except for the two players at the shortest and tallest ends, because most players are within 6 to 7 inches of the center, you are correct. We can see that if our basketball player's center is 80 inches, then if we go to the left, that would be 80 minus 6, you will see that we will end at 74. And if we go to the right, you will see that 80 plus 6 will take us to 86. So it seems as if 80 to 81 is approximately the center of the heights for our basketball players. If that's what you said, excellent work. Let's move on. Question number 3. Please pause this video, read question 3 to yourself, and then we will read it together. Alright, welcome back. Question number 3 reads, write 2 to 3 sentences that describe the distribution of the heights of the baseball players. Comment on the center and spread of the data. Okay, so with that said, what did you get? Please pause the video and let us know. What did you get for the distribution of the data for histogram B? Alright, welcome back. If you said the baseball players' data distribution is centered at around 72 inches, the spread is also similar to the basketball players' data, and all the players are within 6 inches of the center of the data, then you're correct. Now remember, for question 2 and 3, there's a couple of different ways we can rephrase these answers, but this is pretty much what it is. So for number 3, when we're talking about the baseball players' data, we can see that the majority of them are pretty much in this cluster between 70 and 76. And if we say the center of the data is 72, we will notice that to get from 72 to 66, that is a difference of 6. We can do 72 minus 66, and that will show you that that difference is 6. And we can move in the opposite direction and do 76 minus 70, and we will also get 6. So we can see that 72 is in the middle of all these heights because 6 units to the left is 66 and 6 units to the right is 78, which pretty encompasses encompasses all of our values. All right, let's move on to explore part C. What I want you to do is to read the story, look at these 2 histograms, and let me know, what do you think and what do you wonder? All right, welcome back. So let's read the story together. The story says the 2 histograms show the points scored per game by a college basketball player in 2008 and 2016. Some of the things that you might have wondered is, what does the x-axis represent and what does the y-axis represent? In this particular case, for both of these histograms, the x-axis represents the points per game, specifically in 2016. That's for this histogram. But for the histogram on the left, it says points per game in 2008. Okay, so with that said, what does the y-axis represent? Please pause the video and let me know. All right, welcome back. If you said the y-axis represents how many games the player has played, then you are correct. So the y-axis represents how many games have we played that we scored a specific amount of points in that game. So for example, this first bar represents that specifically in 2 games, we scored almost 5 points. So with that said, let's look at number 1. Please pause this video and read number 1 to yourself. All right, welcome back. Let's read number 1 together. Number 1 says, what is a typical number of points per game scored by this player in 2008? What about 2016? Explain your reasoning. Okay, so let's take a look and see what happened in 2008 and what happened in 2016. So because we are interpreting data, there's many different ways you can answer this question. So your answers could vary. So here's the response. In both seasons, the player typically scored around 15 to 20 points in a game. In each histogram, the typical score should be around the center of the spread of data. So basically what we're saying is that he's scoring between 15 and 20 points in both seasons. We can see in this season, he scored the majority of his points between the 15 and 20 points per game column. And we could see in 2016, it is the same. This person also scored between 15 to 20 points in that range. If this is the answer that you got, then you are correct. All right, let's look at question number 2. Please pause this video and read question number 2 to yourself. All right, welcome back. Question number 2 says, write 2 to 3 sentences that describe the spreads of the 2 distributions, including what spreads might tell us in this context. Please pause this video and let me know. What do you think? All right, welcome back. If you said the spread of data was more narrow in 2016 than in 2008, although the player was more consistent in 2016, she had a really great game in 2008 that changed the spread of scores. If this is what you said, then you are correct. Remember, there's many ways you can phrase this answer, but this is one of the correct ones. We can see that in 2016, the majority of the scores were pretty much all clustered together. However, in 2008, we have this one game where our athlete scored between 40 to 45 points. So this shows that in 2016, the data was a little bit more narrow, a little bit more close together, versus in 2008, where we had some games where we scored very few points. We had some games where we scored a tremendous amount of points. And then we had our games where we averaged between 10 to 20 points. All right, ladies and gentlemen, thank you so much for watching this video. I hope this video has been helpful to you. My name is Mr. Cantor, and I will see you in the next one. Take care for now.